Class 2 wiring is governed by specific requirements within the National Electrical Code, commonly referred to as the NEC. It's essential to understand these requirements to ensure electrical installations are safe and compliant. When it comes to splicing Class 2 wiring, the NEC does not permit open-air splices. An open-air splice refers to a connection between two or more conductors that is not enclosed within an approved junction box or other suitable enclosure. The reasoning behind this restriction is to prevent potential hazards associated with exposed connections. These hazards can include electrical shock, fire, and interference with other electrical systems. The NEC mandates that all splices and terminations must be made within approved enclosures. These enclosures provide physical protection to the connections, preventing them from being accidentally damaged or coming into contact with conductive materials. Enclosures also protect the connections from environmental factors such as moisture and dust, which can lead to corrosion and other problems. In the context of Class 2 wiring, which typically involves low voltage, low energy circuits, the need for proper enclosures might seem less critical than with high voltage systems. However, even low voltage circuits can pose a risk if not installed correctly. An exposed splice could create a short circuit which, while not as dangerous as a short circuit in a high voltage system, could still damage equipment or cause a fire. Furthermore, the NEC aims to ensure that all electrical installations are reliable and maintain their integrity over time. Open-air splices are more susceptible to damage and degradation than enclosed splices, potentially leading to future problems. Several types of enclosures are approved for use with Class 2 wiring. These include junction boxes, splice kits, and other enclosures specifically designed for electrical connections. The choice of enclosure will depend on the specific application and the environment in which the wiring is installed. It's important to select an enclosure that is appropriately sized for the number of conductors and connections it will contain. The enclosure should also be rated for the environment in which it will be used. For example, an enclosure used outdoors must be weatherproof to protect the connections from moisture. When making splices in Class 2 wiring, it's essential to use connectors that are specifically designed for the type of wire being used. Different types of connectors are available for solid wire, stranded wire, and different wire gauges. Using the wrong type of connector can lead to a poor connection, which can cause problems such as overheating and voltage drop. In addition to using the correct connectors and enclosures, it's also important to follow proper wiring techniques. This includes stripping the insulation from the wires carefully to avoid damaging the conductors, twisting the wires together tightly, and ensuring that the connectors are properly tightened. The NEC provides detailed guidelines for making electrical connections, and it's essential to follow these guidelines to ensure a safe and reliable installation. Some specific sections of the NEC that are relevant to Class 2 wiring include Article 725, which covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. This article provides requirements for the wiring methods, overcurrent protection, and other aspects of Class 2 wiring installations. Other relevant articles include Article 300, which covers wiring methods in general, and Article 314, which covers junction boxes, pole boxes, and handhole enclosures. These articles provide requirements for the installation of enclosures and other wiring components. It's also important to consult with local electrical codes and regulations, as these may have additional requirements that are not covered in the NEC. Local codes may vary depending on the jurisdiction, so it's essential to be aware of the specific requirements in your area. When working with electrical wiring, it's always important to take safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing the circuit before working on it. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician to do the work. In summary, the NEC does not allow for open-air splices in Class 2 wiring. All splices and terminations must be made within approved enclosures to ensure safety and reliability. It's important to follow proper wiring techniques and consult with local electrical codes and regulations to ensure a compliant installation. Understanding the NEC requirements for Class 2 wiring is crucial for anyone involved in electrical work, whether you are a professional electrician or a homeowner doing your own repairs. By following these requirements, you can help to ensure that electrical installations are safe, reliable, and compliant with all applicable codes and regulations. Always remember to prioritize safety when working with electricity and to consult with a qualified electrician if you have any questions or concerns. In addition to the NEC, other standards and guidelines may be relevant to Class 2 wiring installations. These include standards from organizations such as Underwriters Laboratories, commonly referred to as UL, and the National Electrical Manufacturers Association, also known as NEMA. UL standards provide requirements for the safety and performance of electrical products, while NEMA standards provide guidelines for the design and construction of electrical equipment. It's important to be familiar with these standards and guidelines to ensure that the products and equipment you are using meet the necessary safety and performance requirements. When selecting Class 2 wiring, it's important to choose wire that is appropriate for the application. Class 2 wiring is available in a variety of types and sizes, each with its own specific characteristics. Some common types of Class 2 wiring include thermostat wire, security system wire, and low-voltage lighting wire. The size of the wire is determined by the amount of current it will be carrying. The NEC provides tables that specify the allowable ampacity of different wire sizes, and it's important to choose a wire size that is adequate for the load. When installing Class 2 wiring, it's important to follow proper wiring methods. This includes using appropriate supports and fasteners to secure the wiring and avoiding sharp bends or kinks in the wire. The wiring should also be protected from physical damage, such as being run through conduit or other protective raceways. In some cases, it may be necessary to use shielded wire to protect the circuit from electromagnetic interference. Shielded wire has a metallic shield that surrounds the conductors and helps to block out unwanted signals. This is particularly important in applications where the Class 2 wiring is located near other electrical equipment or sources of interference. When terminating Class 2 wiring, it's important to use connectors that are specifically designed for the type of wire being used. These connectors should be properly installed and tightened to ensure a secure connection. It's also important to avoid over-tightening the connectors, as this can damage the wire or the connector. After the wiring is installed, it's important to test the circuit to ensure that it is working properly. This can be done using a multimeter or other testing equipment. The circuit should be tested for continuity, voltage, and current to ensure that it meets the required specifications. If any problems are found, they should be corrected before the circuit is put into service. Regular maintenance and inspection of Class 2 wiring installations are also important. This can help to identify potential problems before they become serious. The wiring should be inspected for signs of damage, such as cracked or broken insulation, and the connection should be checked for tightness. Any problems that are found should be corrected promptly. In addition to the technical aspects of Class 2 wiring, it's also important to consider the aesthetic aspects. The wiring should be installed in a neat and professional manner, and it should be hidden from view as much as possible. This can help to improve the overall appearance of the installation and make it more visually appealing. When working with Class 2 wiring, it's always important to be aware of the potential hazards. Although Class 2 circuits are low voltage or low energy, they can still pose a risk of electrical shock or fire. It's important to follow all safety precautions and to consult with a qualified electrician if you have any questions or concerns. The NEC provides a comprehensive set of rules and regulations for the installation of electrical wiring, including Class 2 wiring. By following these rules and regulations, you can help to ensure that electrical installations are safe, reliable, and compliant with all applicable codes and standards. Remember that electrical codes and standards are constantly evolving, so it's important to stay up to date on the latest changes. This can be done by attending training courses, reading industry publications, and consulting with qualified electricians and electrical inspectors. By staying informed and following best practices, you can help to ensure that electrical installations are safe and efficient for years to come.